The HVAC School podcast is made possible by these great sponsors. Carrier and Carrier.com. Carrier has been a long-term sponsor of the podcast. They've made it possible very early on for us to do what we do, and they are the products that we sell day in and day out. Everything from single-stage equipment all the way up to the Green Speed Extreme, one of the most efficient products on the market today. Find out more about what Carrier has to offer and about becoming a Carrier dealer by going to Carrier.com. The Navac NX1 Nexus Digital Manifold Gauge. Compatible with over 72 refrigerants, including the newly popular A2L refrigerants that we keep talking about, R32 and R454B. Among the highest accuracy manifold gauges in the industry, they offer a clear digital display, giving you precise readings at a glance, and they integrate with the My Navac app, Navac temperature probes, and Navac's premium micron gauge. So now you can monitor system pressure, temperature, and vacuum all in one app. To find out more, go to hvacrschool.com/NX1 or go to navacglobal.com. Refrigeration technologies at refridgetech.com, and specifically the new Viper Wet Rag Heat Shield, the revolutionary flame-resistant welding pad designed to be used either wet or dry. Find a Viper Wet Rag Heat Shield at a distributor near you or go to TrueTechTools.com and use offer code GetSchooled for a great discount at checkout. FastStat at fast-stat.com. You know what a pain it is when you're trying to upgrade a thermostat and you need extra conductors and you ain't got them. Well, FastStat has several different models, some of which add a common or control wiring and some which merely extend it. Great for adding accessories or, in the case of a system replacement, no batteries or programming required. You can find FastStat at major supply houses all across the fruited plain, and if they don't have it, you demand the manager get it. Just do the Karen thing and ask for FastStat by name. Find out more at hvacrschool.com/fast-stat. That's hvacrschool.com/fast-stat. The Esco Institute, with over 200 HVACR training solutions, courses, webinars, and simulators. Find out more by going to escogroup.org.
And now the man who never leaves the disconnect out or the caps off, Bryan Orr.
This is the HVAC School podcast. Not that there's anything wrong with that. And today we're going to be talking with Craig from AC Service Tech. It doesn't matter if I know how to say his name or not. Whenever I get on a podcast, I say it wrong. Migliaccio. I think that's how you say it. Something like that. Craig's the guy we all look up to. He makes some of the best videos in the trade. I would argue probably the best videos in terms of giving very specific information. He's always very concerned with being accurate and detailed, and I really appreciate the heck out of him. Super great guy. And so Craig's who I call when I have a question about something that I don't really do a lot, especially as it relates to furnaces, that kind of thing. Craig's from New Jersey, so he's worked on a lot of high-efficiency condensing furnaces. So Adam Blunkall had some questions. He also made a really great post on HVAC School, a tech tip. So take a look at the tech tip as well. He's a tech from Tennessee. And he had some additional questions that we probably didn't answer, but at least we talked around it because, again, this is one of these things, we'll mention this a bunch, that the way that the code is enforced really varies from market to market on condensate, shockingly so, on the AC side, but then also on the condensing gas furnace side, high-efficiency furnace side. So anyway, Craig and I talk about that, and that's the topic of this podcast, which you saw when you clicked on it. So I don't know why I keep having to restate it. But anyway, here we go, talking about Condensing Furnace Drain Guidance with AC Service Tech. Thanks for joining us on the HVAC School podcast, Mr. Migliaccio.
Thanks for having me, Bryan. I always appreciate being on here with you.
Yeah, it's good seeing you again. We had a question. Actually, it was a bunch of tips, and then it was also a question that came in from a guy named Adam. And we're going to maybe address some of the things that he asked, but we're mostly just going to talk about high-efficiency gas furnaces and there's specifically the condensate side of things, which does seem to be a common topic. So I thought it'd be good to jump on with somebody who knows a little bit more about it than I do, because in Florida, we don't have very many high-efficiency furnaces, at least not yet. So start with the basics for people who just don't even understand this. Like, what? A drain on a furnace? Like me when I first started. I'm like, I've never seen a drain on a furnace before. Why is that there? What's that all about?
So for a furnace to jump from an 80% efficient to a 90% efficient, you're going to have two heat exchangers. One's the primary and one's the secondary. Whereas on an 80%, you're only going to have a primary heat exchanger. And what happens on an 80% efficient furnace is there's an inducer motor. So basically, that's a step up from the 70% that didn't have one. So the inducer motor actually is able to allow the drafting process. Basically, it's actually pulling the exhaust through the heat exchanger, but downstream of that inducer motor, it's then just drafting upwards until it goes out the exhaust. On a 90% efficient furnace, it's pulling it through and is pushing the exhaust out of the furnace with positive pressure. And so you have the secondary heat exchanger making contact with the air, the conditioned air from the house first, and then it's going through that and over to or around that, and then around the primary heat exchanger, which is going to be higher. So what's really happening here is the exhaust is cooling down so much, or it's lowering in temperature so much because it's rejecting that heat to the air to where it condenses. And so basically one of the byproducts of the flame process is water vapor. And so you're condensing that water inside the heat exchanger, and you're extracting more heat from that so that the exhaust from a 90% efficient furnace is like the temperature of your skin. So that's why you have your lower temperature exhaust and condensate in your secondary heat exchanger making contact with the air first because it's lower temperature. So your air is heating up there, and then it's going by the primary heat exchanger, which is just exhaust, hot exhaust, and it's heating up more to go into the building.
The first time I saw it, I was like, what? Wait, the cooler one is first? And yeah, it makes sense because you need to be able to get that heat transfer needs to occur. And so we'll say 70 degree air inside the space, and you want to be able to get heat into that air from the secondary heat exchanger first because it's cooler, then it goes to the hot one. I don't know that I helped explain that at all. A couple things that Craig mentioned here that are just worth noting in case you're somebody who maybe you're an alien and you just came here and you've never seen a furnace before. Who knows? Or you're new to school or you're a homeowner. If you see PVC going out of your furnace, it's going to be a high efficiency furnace. And that's what we call a 90% or a 90 plus or a condensing gas furnace. They'll use those terms and they're fairly interchangeable. And that just means that the discharge coming out of that, the actual products of combustion, like Craig mentioned, are very cool, very low temperature, so it's not going to damage PVC. And they are going to be at that point where you started condensing that moisture out. And so you've got to deal with that, which is also why on your secondary heat exchanger and that whole assembly, you're going to see more products like stainless steel and plastic, things that are going to withstand that corrosion. So talk a little bit about that because a lot of people don't understand that. That condensate does tend to be more corrosive condensate than you would see from your AC drain.
Yeah, so because of that acidity, it can even break down that PVC exhaust. So basically, you could utilize polypropylene now for the exhaust instead of the PVC. But now down in the condensate I should describe that really because you're going to have some of that water vapor still condensing even in the exhaust. And so it needs to be a 1/4 inch of pitch upwards until it exits wherever the building at, or it can go much higher of a pitch. And as that water vapor is condensing, it's going to then drip and come back and flow back to the furnace, back into that heat exchanger, and it's still going to be able to provide heat. So if it's at 90 degrees still and you have 70 degree air, the air is still going to absorb heat from that condensate from all the way over in the exhaust that's trickling back down. Now, as the furnace condensate trails away from or drains away from the furnace, it's going to be acidic. So it might have a pH of maybe 3 to 5. It really depends on the furnace and the extraction of heat, the temperature, how good the combustion process was. So you can't just drain that right into, say, a 1950s drain, basically a drain line assembly that might be copper or something that can corrode. So you may have to add a neutralizer onto that if the condensate drain was eventually going to be going into the septic line.
So it depends on, obviously, one of the things that's always worth mentioning here right off the bat is depends on site conditions, depends on local codes, whatever the AHJ is requiring. And when you talk about condensate, it's one of those things. It's like really depends a lot on where you are, what the common standards are. You see a lot of cases where it might drain into a floor drain that's right there or something like that. You have some cases that it's going to go into the sewer system in some locations. You have some where that's not the case. And like you said, maybe you have a septic system. Maybe it's going out like in our market where you have AC condensate just going out onto the ground. Again, one of the big concerns that Adam was bringing up was about freezing. So one thing that I wanted to mention quickly, because we were just talking about the venting. When I first heard about it, I was like, oh, well, it makes more sense that that condensate and the venting would drain out, that you would pitch it outwards. But like you mentioned, there's actually still heat contained there. But in addition to that also, if you were draining all that condensate and that venting outward, you would get more issues with freezing at the outlet.
Yeah, so there's a bunch of different things that you want to take into consideration, even with a 90% efficient furnace. What is nice about those is you can run that exhaust pipe right out the side of the building. Once again, you have to follow the codes. You got to keep away from windows and things that can open for the fresh air. And so you also have to stay a certain amount above the ground. And once again, that'll have to be with your local conditions because there might be a lot of snow in that location and that could clog it up. So there's a lot of considerations for that. But as far as the drain line, there's a lot of different ways to drain a 90% efficient furnace. So if you were to exit out with 1/2-inch CPVC, you can continue that with 3/4. We typically would go to 3/4 just because it's more rigid. And then you're going to have to support that, say, every 3-4 feet. And if you want to go 2 feet even, we usually use Schedule 40 and secure that in place. Technically, by code, it needs to be 1/8 of an inch of pitch per foot downwards away from the furnace or more. And we typically run at least like 1/4 inch. We don't want any bellies in the pipe or things that would end up clogging because if that water's just left there, it could be creating like biological growth and end up like clogging that up eventually. So those are definitely some concerns. And you can drain it into a lot of different places. There's a lot of different methods to drain, but to go to your point, if we were to just go directly outside, like in my area in New Jersey, you are not going to want to necessarily just run a 3/4 drain right out the side of, say, the foundation wall. And if you did, you'd put a 45 or 90 degree on it, something to where the air is not going to come in and, say, pressurize the pipe, and it's not going to lower the temperature inside the pipe as fast. So you'd put a 90-degree elbow on it. But a lot of times that's going to freeze over because there's just not enough heat. So basically, as the condensate goes down inside the condensate line, travels across in the crawl space. And I have crawl spaces here. And in Florida, it's like a lot of slabs. But in the crawl spaces here, it's 50, 55 degrees, 60 degrees down in there. And it's going to lower in temperature there. And then by the time it exits, it can potentially freeze over. So sometimes we drip that condensate line into a larger condensate line that exits through the foundation wall. We literally have done 1.5 or 2-inch PVC elbows. So you have an elbow up in the crawl space and then another one outside the crawl space on the foundation wall going downwards. And we'll drip our 3/4 condensate line so there's an air gap in between these two pipes, but not enough to where that would make noise for the homeowner. So that's just a way for us to try to protect against potential freezing, but that does leave a big opening for like bugs and things like that to get into crawl space.
Yeah, it's a trade-off. And I guess by using a pipe that big, it's just decreasing the likelihood that it's going to freeze and build up ice that covers that entire gap. Theoretically, you could still eventually even block up a larger pipe. It's just going to be less likely. Is that the thinking there?
Absolutely, yeah. So we've seen 1.5-inch pipes frozen completely solid, and you'll have halfway up the pipe or 3/4 of the way up the pipe, and it's still draining out. It just depends on how low the temperature is outdoors and for how long. So most of the time, we're fine. It's not a problem at all. But once those low temperatures hit, you get a lot of no heating calls, and those condensate lines are frozen over. So you then find an installation problem that somebody else had that they were able to get by for a couple of years, but then this year they weren't able to.
This is just me going completely off the script here, but do you ever run into cases where people will use something like heat tape through the crawl space or something like that to completely prevent the issue? I mean, because that's what we do in refrigeration is use of heat tape.
You could certainly do that too because you are lowering the temperature of that PVC while it's running through horizontally in the crawl space. That's definitely something that you can do, but that air gap. So like we're really talking about 1 or 2% of the time, at least in my area. So that's why we provide that little air gap between that, say, 1.5-inch PVC that's exiting through the wall and the 3/4 PVC because it has enough heat to where it's still in liquid form, but that pipe exiting the building might be completely frozen up. So then it will drip in the crawl space. We don't really want dripping in the crawl space, obviously. But the problem is it's like you do need heat. It's a necessity. And a lot of the codes are difficult for like where we're going to drain this, which I know we're going to talk about that too. So instead of putting something electrical or drawing electrical power, that's why we've provided that little air gap. And I'll drip it like into the turn of the 90 so that it doesn't make that dripping sound. It rides as it drops.
So it's not like plopping in there. Got it.
I want to take a second and talk to you about the Navac NX1 Nexus digital manifold gauge. I got to take a look at the early version of this at AHR. It's an easy-to-use smart manifold gauge and integrates with the Navac temperature probes and Navac's premium micron gauge, the NMV1S, so that way you can monitor system pressure, temperature, and vacuum all together. And it integrates with the My Navac app, allowing you to export your field data for future reference, for reports, that kind of thing. Gives you a clear digital display, a handy-dandy foldable hidden hook. It is one of the most accurate manifolds in the industry. It has quarter-turn ball valves, which are really nice. Impact-resistant aluminum body covered in a durable rubberized coating to withstand the rigors of the HVAC field. And it's compatible with over 72 refrigerants, including R454B and R32. To find out more, go to hvacrschool.com/NX1. That's hvacrschool.com/NX1, or, as always, go to navacglobal.com.
Let's talk about the idea of tying together the furnace drain with the AC condensate drain, because that happens a lot. Would you agree that it's a best practice to keep them separate whenever possible, or would you disagree with that?
It's a tough one. You're going to have to run two lines away from the furnace and air conditioning system, and you're going to, at some point, probably tie together or drip together. And it's difficult because what we're really talking about is two things. One, if the furnace trap, the condensate trap, dries up, then basically, so if it dries up, but you also have combustion happening, and also the evaporator coil condensate trap dries up, then technically you could get some exhaust fumes into the evaporator coil. But if you do have combustion, then that means that your condensate trap has water in it because the pressure switch is not going to function properly if your condensate trap is dry. So you have a couple competing things here. So it's like a worst case scenario. So that is not very likely at all that you would get exhaust gases into the conditioned space via the exhaust through the dry trap, through another dry trap into the evaporator coil, but it would be lower in pressure, so technically it could potentially draw if they were dry. The second issue is if they are tied together and you have a clog downstream of both of them, then the water would basically back up. And if you had a vertical furnace with an evaporator coil on top, then it is possible, I have not seen this, but it is possible for the bottom of the inducer motor housing in areas like that to fill up with water, and the primary heat exchanger to then fill up with water, back up with water. But it's not very likely that that would happen. Now, that also might potentially cause a little bit of a pressure jump that might trip the pressure switch temporarily, but not likely because it depends on what type of pressure switch you have. A lot of them have like an atmospheric port, and if that's the case, it's not going to be an issue. So, with all that being said, if you did tie them together, if your codes did allow it, like your local codes, then what you really want to do is you want to have a condensate switch that is downstream of both of these locations in the horizontal position, so that if that line filled up with water, it would open up the electrical circuit to the low voltage thermostat wires going to the furnace. So that would be a safety precaution that you could do if you had to tie them together. A lot of times you will find that people are tying them together. Now, I did look at the end of the codes on it in the IMC, the International Mechanical Code, and the IRC, and they are just writing basically that, hey, from the evaporator coil, you're just draining directly from there to the outlet, and then it's from the furnace condensate directly to the outlet. It doesn't mention tying them together, but a lot of local inspectors and codes might stipulate that you cannot tie them together. So it's definitely an issue. They've never made it easy for us. They've never made it easy for us with these 90% efficient furnaces, and we'll get into that in a little bit too.
Okay. I'm interested in getting into that. So to your point, though, one of the things that was brought up by Adam that I think is worth just mentioning is that, yeah, it is possible when you have an evaporator coil on top of a condensing gas furnace that when it's running in AC mode, it could back up into the furnace first because the furnace is lower. That can happen. Now, and is it bad for the unit? Sure. I mean, stuff's not supposed to fill up with water like that, so that is bad. But it's all designed for corrosive condensate, and your condensate from your evaporator coil is not corrosive. So is it the end of the world? I don't know. I mean, have you run into situations where you can attribute failures or issues that you think was due to AC condensate backing up into the furnace? Is that something you've run into?
I actually haven't seen it in the first device that would technically fail from that. Would either be the pressure switch, depending on its location and the tube mounting, because sometimes the tubes go right to the bottom of the inducer motor housing and the pressure switch is mounted below the inducer motor housing, but sometimes it's mounted above. It also depends on the position of the furnace, horizontal right, left, upflow, downflow. But the other device that could get damaged is the inducer motor if the water level rises up above the bottom of where the inducer motor is mounted at, essentially. And that would have to fill up a lot. And we're also really talking about a vertical furnace. You could have other issues with a horizontal furnace, but I actually have not seen that in all the years of servicing furnaces around here. And like I said, we're in New Jersey, and as soon as I started doing HVAC work, our changeouts, everything, even if they had an 80% efficient furnace, a lot of times we would be switching that out with a 90% efficient furnace, and we would figure out a way to get that venting out right through, say, the ceiling, basically. If there's 2x10s or something like that, we would get enough pitch to go horizontally out the side wall. Like, we would figure out ways in order to get that exhaust outside, because a lot of times the building owners around here want a higher efficiency. And I know down where you're at, that's a completely different story, because it just doesn't pay off for the extra parts, the extra cost, extra installation, all of that stuff.
So again, what the suggestion here is, and this is maybe somewhat hypothetical for some people, depending on the situation, but if you can put a condensate switch past, so in a horizontal section, and I guess at that point you'd be doing it, and we're talking about an inline condensate switch, which I'm never like a huge fan of anyway, because of the fact that the float sits in the line, and sometimes I think makes the issue worse. I know it does in some cases. But the idea there is that then you could break red on the furnace and it would shut off everything. So cooling wouldn't work, heating wouldn't work, and it would reduce that chance that you're going to back up into, you're catching it before it backs up into the heat exchanger. Again, I think we may be solving for some problems that don't really happen that often. And I think the standard practice is still going to be, you just have your standard condensate switches on your AC and then really nothing on the furnace. Most furnaces, other than the fact that once it backs up and is trying to run, then it's going to shut off because of the internal to the furnace itself.
In the code books, they actually do stipulate to put an auxiliary drain pan underneath of a 90% efficient furnace. I can't remember if that's IMC or IRC, or it might be both, actually. But you technically are supposed to put that there, and either you have to have a drain from that pan outside, which I don't like. And all the pans typically come with a hole in it, and I have to plug the hole. It's ridiculous. But I think nowadays we don't have that problem. They sell more varieties of pans. But the pan is supposed to be at least 3 inches bigger than the appliance, essentially, whether that's a furnace or whether that's an evaporator coil or it's a combination of both. It needs to be 3 inches past on all sides. And so we put some type of condensate switch. I used to say float switch, but now there's so many different types of switches that to sense any water in the pan, it is best to also, if you are using a float switch, to pitch it, like angle it, so it does not take much water in order to trip it. That's the biggest problem that I see, is that people will put a float switch, they won't test it, they won't angle it, they won't do anything. And I've actually seen pans overflow with the switch on it many times. I've also seen bad designs where it's just like a plastic piece instead of the foam piece or something like that. It doesn't have enough buoyancy. Once again, it overflows out. Anyway, so on a 90% efficient furnace, you typically are not seeing pans underneath of them out in the field. Like, there typically is not. But it technically does say that you're supposed to. It also depends on what the municipality has adopted as their code book. You really have to do that. But you kind of want to be friendly with your code inspector and not call them out or anything like that, because then you're going to have problems forever. But at the same time, you do want to get to, like, if there's a problem with you not aligning to the codes, you do want to see where it is. You do need a reference. It's not good enough to say, you don't pass, fix it. That's not okay. You have to figure out a way to nicely communicate that you would like the code reference just for future use. You want to say it like that. Like, hey, I don't want this problem to occur like there in the future. Can you just give that reference to me, and also maybe the interpretation of that reference, so that I'm totally good for here on out and you're going to be thrilled with all the jobs that I do in the future.
I like that speech. That was convincing.
So I want to take a moment and tell you about a fantastic resource for professionals like you in our trade, the Esco Institute and the HVACR Learning Network. Whether you're looking for NATE credits, or you're looking for EPA prep, or you're looking to get ready for A2Ls, all the stuff that's coming down the line. Our friends over at Esco Institute, Jason, Eugene, Clifton, Howard, Jerry, all great guys who have worked tirelessly to put together a lot of great information, people who we know and trust, from industry-leading organizations, authors, and publishers. The HVACR Learning Network, or HLN, is a source for HVACR professionals like you to access digital content with confidence. You can be sure you're getting reliable, up-to-date, and relevant material directly from trusted sources, Plus, like I said, you can often earn continuing education hours while you're at it. Whether you're looking to enhance the knowledge of students, employees, or even yourself, you'll find the resources you're looking for in their warehouse of titles. The team at HLN is passionate about providing the best educational content for our industry, and I'm personally grateful for their hard work. So if you want to stay ahead of the game and continue growing as an HVACR professional, I highly recommend checking out the HVACR Learning Network. Just visit hvacr.elearn.network to start exploring their extensive collection of resources. Again, big shout out to their whole team for their dedication to our industry's education. All right, back to the podcast.
I guess the point here is that there are a lot of things to think about here. Inline condensate switches, like I've said. So if we're talking about a primary drain line, putting inline condensate switches is a very commonly adopted method, and I know that it is effective in some cases. I don't love it for the reason that I've already stated, but that is a method you could do. You could do it past, so a horizontal portion that's actually right before it goes out or wherever it's going, you could put it there, and that way it would catch both things. That's what Adam was saying. Is that the best practice? Well, like you said, if you have a pan underneath it, you could just put a pan switch underneath there, and then the likelihood that it's all just going to tightly hold water when everything's backing up, it's probably going to happen pretty quickly. And so it's going to probably leak down into the pan and shut it off. I don't know. I haven't actually tried it, but that's another practice that you should follow. Oh, by the way, if you are using multiple switches, make sure you're wiring them in series with one another so that if any one opens, just like a safety circuit, if any switch opens, it shuts off everything. That's the goal. I don't know, though, from your perspective, what's your best practice? What would you advise people to do? We're not speaking as code officials here, but just to try to hit on what the code's trying to get at here, I guess.
So one way to avoid the whole problem, so I'll tell you the problem. So yeah, the problem is the codes tend to avoid the problem, and they always have. Nobody wants to take responsibility of it. And there's a lot of things that you have to consider, like say an acid neutralizer in the condensate line. If you are connecting it somehow into the septic line, and it's not ABS or not PVC drain lines, you're going to want to put a acid neutralizer in, and you're going to need to replace that at least once a year. That's one thing to think about for the furnace, just due to the acidity of it. It's not crazy acidic, but it is acidic enough to potentially do some damage. So that's one thing. The second thing that you should take into consideration is condensate pumps are a good alternative to not tying things together, because technically there would be an air gap. If you put both the furnace drain and the evaporator coil drain into a condensate pump, then you can avoid any type of air gap. Now, what I typically do, say on an upflow furnace that doesn't have a trap on it, I've actually measured the amount of CFM that it expels basically out of the system, and I don't like that to come straight outside. So when using a condensate trap, I try to get it down low, and I'll cut my pipe on an angle, and then I'll set it down into the bottom of the condensate pump, so the water level inside the condensate pump that's always there will provide a trap method, but also there's enough of a gap to where it's not going to clog up with biofilm and things. The other thing is some condensate pumps come with acid neutralizer built into it, or a cartridge that you can replace. So that's another alternative. And condensate pumps are a good alternative if you are already lower in pitch than, say, even if you're in a crawl space. Like we have a lot of crawl spaces with fiberglass insulation around here underneath of the building. And they might just literally be 3 foot, 4 foot. Some are taller, some are basements. And some places don't have floor drains. And so we also live in a coastal area, so we're trying to avoid any moisture in the crawl space that could end up creating mold growth on the wood and having major problems around here. This is a big deal. You have to have ventilation. That's a whole nother subject, completely whole nother thing. But the whole point is, if you just drain it into the crawl space without thinking about it, it might not literally go anywhere, and that would be an issue. And even if you did drain it, say, into the crawl space, you end up getting a layer of film on it. I've seen that. So then it stops the drainage of the water literally and pools up. And so in the past, sometimes you'll see people use like a 5-gallon bucket. They'll cut the bottom out. They'll dig that down into the crawl space and they'll have stone inside of it and they'll drip it into there. That's only if you have a low ground level area where the water from the ground is not coming up that high. Around here, it's like 2 foot. It's not good. So a condensate pump in a crawl space, you're going to need to drain it into that just to pump it up to even get it out to where I was talking about before, like even to your 1.5 PVC that exits the building. So you'd have your condensate line, your flexible line attached to a 3/4 PVC, and then your 3/4 PVC dripping into that end. I typically am not trying to shoot my water from the condensate pump into that 1.5. So it's a couple transitions, but I typically have not had any problem with it going from a 3/4 PVC and a barb fitting over to the poly tubing, and then the poly tubing over to the pump. All that to say, too, your pump needs to have a safety switch, and you need to have that wired in series with your other safety switches that you have, say, at the evaporator coil pan. That's a possibility of something that you can do. If you're inside the building, say you're up in an attic or in the living area, you can use a condensate pump to pump it into, say, a standpipe in the septic line. But once again, it has to be neutralized if it's, say, a metal septic line. So you can run that technically by code into a standpipe, and a standpipe is something like you have behind your washer that comes up, say, 2 foot, has a trap down below it, and you could drain it technically into there. And there's a coated denim so that you can actually attach it into below a lavatory sink. I'm not exactly sure how that's stated, but technically it says it counts like you can. You definitely have to reference the code on that. You're going to have to read that code yourself for that. It's 307 period 2, I believe, in there for condensate drainage. So check that out before doing that. But I know you can drain it into a standpipe. I know you can drain it into a utility sink, or like you mentioned, a floor drain and a mop bucket floor drain. You can drain it into any one of those spots as well. But you want to have the most professional looking job too. It's a shame that you can't tie it directly into a septic line. Even if you have a trap, put a trap into it. Number one, as an HVAC tech, you're not supposed to be cutting into the drain lines, so you can't really touch the main drain line anyway. And if you did, you'd have to have a Y fitting and a trap, and you can't directly connect into it anyway, because you have to also have a standpipe, and you also have to have an air gap. That's the joke. It's like, thanks, guys. They don't want to tell us what to do, so they just avoid it.
Yeah, and I think it's just one of these things, because especially you have historic homes, you have new construction, you have all these different applications where in some cases it may be easy to do things in an ironclad way, but in other cases it may be very difficult. I pulled it up. So we're referencing the IMC 307.2, and it says you cannot discharge into a plumbing fixture other than a floor sink, floor drain, trench drain, mop sink, hub drain, standpipe, utility sink, or laundry sink. It's actually quite a few options there. They don't want you draining into like a vent or something. That's not one of them. And again, a lot of the concerns just have to do with trying to isolate between, for example, you want to isolate your combustion from your AC, or you want to make sure that your AC is isolated from sewer gases. You wouldn't want to pipe, and again, we're talking about 90% furnaces here, but you wouldn't want to pipe an AC condensate drain on a fan coil with negative pressure into a vent that's going into the sewer. Like, that would be pretty bad, especially not at your house, because I know how it gets there at times. So,
oh, thanks. Gee, thanks. You've never been at my house. I've been at your house.
I know, not yet.
All right. Hey, anytime. So in the bottom of that, 307 period 2 period 1 period 1 of the IMC, in that same paragraph, it says a little bit lower, it says condensate line connections to a lavatory Y-branch tailpiece or a bathroom overflow pipe shall not be considered as discharging into a plumbing fixture. Meaning, like the front of it, the beginning part, it says condensate drains shall not directly connect to any plumbing drain, waste, or vent pipe. Meaning, like, these are acceptable areas. That's the way I read it. That's something to just keep in mind. You definitely need to find what adopted codes your municipality is following, for sure.
And it's above my pay grade sometimes, frankly. A lot of people get annoyed with me that I don't talk about codes more, but it's a lot because, especially where things are not commonly adopted or they're not adopted all in the same way, it's like, I'm just going to tell you something and then your AHJ, your local inspector, is going to tell you something opposite. And there are some cases where that's a fight worth having, and there are others where it's just not worth it. And again, as long as ultimately we have to know enough about the systems we're installing to know they're going to be installed according to the manufacturer's requirements and that it's going to be safe for the occupant. And that's what a lot of this comes down to. A lot of this is manufacturer specific. Look at the installation instructions. I know that's boring, but even then, a lot of times they don't solve for every different situation. And that's what you were saying. They just don't make it easy. They just don't make it easy for putting in these 90% furnaces.
Yeah. The more efficient it is, hey, do the high efficiency thing, but we're just going to tell you that you did it wrong after you do it, though. Like, oh, thanks.
Just do it right, and then it won't be a problem. Excuse me, sir, how do I do it right? Hey, stop asking so many questions. Just go do it right. Yeah, it won't be a problem.
When I started doing this, the codes, I don't believe, and like I said, I was young, so I don't know exactly because I wasn't reading code books like 20 years ago. But for us, everything that you tried to do was wrong. That was the problem with the 90% efficient condensate lines. It was everything. They didn't want you going into a utility sink. They didn't want you going into a washer drain, but that could have also been our local inspectors. Like I said, I wasn't paying attention to the codes to be able to know and quote unquote fight back without saying anything harsh to them. I didn't know, but that's what we kept trying to do different things, and they didn't like it no matter what we did. It was always an issue, it seems.
It's one we hear a lot about. So I don't know that we necessarily solved anybody's problems here, but is there any final parting shots or words of advice you would give for people who are struggling to know what the best practice is for them in their market?
Be friends with your local inspector somehow. You want to have a real good relationship, but you want to do great work. So that's why a lot of times they'll respect you because of that. The other thing is a condensate pump avoids you having to connect the two together if you are asked to keep them separate. You want to avoid things like condensate pumps if you can naturally pitch things. But sometimes it does make it possible to be able to do things correctly in order to be able to do your job well. No, that's about it. It's all I have, really. I think we hit on all the topics on this one. It's a difficult situation. When you emailed me about this, I was like, oh no.
Anything but this. And so some of the things that you mentioned about using a larger size pipe or pitching it down or 45 outside, those are good practices. But again, you got to think about snow line. There's just a lot of things that you have to pay attention to. And like you mentioned, you're talking a lot about crawl spaces, but that's common some places and not common at all others. Where slab on grade, there's other places where basements are absolutely what you see everywhere. So the answer is, well, it depends, which is the most annoying answer to ever give. But it was good talking to you either way. And I know Adam probably is not going to be super thrilled with what we had to say here, but we did do a podcast and I got the best of the best on. So can't complain about that.
He's just not good enough.
I asked Ty to come on and he declined, so I had to go with you. So
Ty was not able to. So you got the second best out of the two of us. That's all. Not the second best in general, the second best out of the two of us.
Or it's just bad out of the two, for sure. Thanks, Craig. I always appreciate you, bud.
Well, I appreciate you having me on.
Yeah, good stuff.
Thanks.
A big thanks to Craig. He has some awesome books. I don't know if you've taken a look at them, but if you haven't, then you should. Go to acservicetech.com to find his books. And he's got a great one on inverter, mini split operation, refrigerant charging and service procedures. Really great stuff. He's got a lot of other cool add-ons for teaching that you can find there. And I would encourage you to take a look. So that's acservicetech.com. Again, time and time again, I just want to keep mentioning that what we have currently in the community of people who do what we do is really awesome. It's incredible the way that everybody's collaborating, whether it's Esco, NCI, Measure Quick, Craig, Ty Brannaman, Gary McCready, Chris Stevens, the HVAC Grapevine guys, TEC, the Energy Conservatory, Retrotech, Field Piece, on and on and on. There's all of these companies and businesses that do training, a wide range of influencers who are recognizing that the amount of people who we need in this trade isn't even close. And the amount of people who need educated makes room for all of us. I just think it's cool. So anyway, big thanks to Craig for being one of those guys who keeps the palms open and has a wide tent. Obviously, don't copy his book or his videos or anything like that. He needs to make money on his books. That's how he supports his family. So don't take advantage of that. Buy it. It's worth it. Support people who are doing good stuff. And that's true of all the different organizations out there, Esco, NCI, everybody out there. Make sure that you're supporting people so that way they can keep doing what they do. And again, I have the opportunity to do a lot of this stuff for free because of our sponsors, and that's also cool. But just consider that. Think about the people who are supporting the trades when you make buying decisions. That's all. No browbeating, just good common sense stuff. I have a few jokes about retired people, but none of them work. Thanks for listening. We'll talk to you next time on the HVAC School Podcast.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.